Bismillahirrahmanirrahim. Hi student, in this video I shall discuss the 18 facts about aromaticity. First one is, what is aromatic? Aromatic word is derived from Greek word aroma. Aroma means odor or smell. Originally this word was used for any cyclic compound which have specific odor, which have specific smell, but today it lost its meaning because there are some compounds which have odor but they are not considered as aromatic. There are some compounds which have no odor but they are considered as aromatic. Today we define aromatic is any cyclic conjugated compound which shows stability like benzene. Any cyclic compound which show resemblance in chemical behavior to that of benzene. How we compare the cyclic stability of cyclic compound with the stability of benzene. Just like each atom which have 2 electron, 8 electron in first shell or in second shell show stability like noble gas, just like this, any cyclic compound which have completely filled shell of pi molecular orbital shows stability like benzene. What is completely filled shell of pi molecular orbital? For example, benzene and benzene 6p orbital are present on planar hexagonal ring. This 6p orbital overlap and results in the formation of 3 pi bond. According to MOT molecular orbital theory, 6p orbital overlap results in the formation of 6 pi molecular orbital. Pi 1 is the lowest lying pi molecular orbital because it have lowest energy. Pi 2, pi 3 are degenerate. Degenerate means the energy of these are same. Pi star 4, pi asterisk 5 are degenerate means these two pi molecular orbital have same energy. Pi 2, pi 3, pi 4, pi 5 are called non-bonding pi molecular orbital. Pi star 6 are called anti-bonding pi molecular orbital because it have highest energy and unstable. If we accommodate this 6 electron in these pi molecular orbital, all the electron become paired. When all electron become paired, then we called it completely filled shell of pi molecular orbital, and it result in closed shell structure. Closed shell structure means that the electron become paired in non-bonding or in bonding pi molecular orbital, and it shows stability like benzene. When n is equal to 1 in Hakkar formula, then we call it an aromatic sextet, and it is associated with benzene. The third is closed shell structure. What is closed shell structure? If electrons are filled into the pi molecular orbital, a closed shell structure, that is, all electrons are paired similar to that of benzene, will result only when the total number of pi electron is according to Hakkar number, that is 2, 6, 10, 14. Open shell structure. If the number of pi electron is 4n, then the last occupied shell will have its degenerate pi molecular orbital filled with only one electron each, with their spin parallel, so it will have an open shell structure. Fact 4. What is definition of aromatic? If we compare the stability of planar cyclic conjugated polyenes with that of corresponding open chain for conjugated polyenes, if we take planar cyclic conjugated polyenes, for example, if we take C6H6, that is in cyclic form, and we compare C6 carbon 6 compound in open chain, then if the number of pi electron in cyclic polyene is 4n plus 2 pi electron, then they will be considered more stable than their open chain analog molecule. Such as cyclic planar conjugated polyene are said to be aromatic. So aromatic is defined as any cyclic planar conjugated polyenes which have Hakkar number of electrons are considered as aromatic. What is planar? What is Hakkar rule? First, what is Hakkar rule? Hakkar rule is 4n plus 2 pi electron rule. This rule was first introduced by German chemist Erich Hakkar. This rule explains the difference between the stability of benzene and other cyclic compounds having alternate single-double bond. This rule states that the planar ring will be particularly stable and hence aromatic if the number of pi electron in their cyclic conjugated system is according to 4n plus 2. If n is equal to 0, 1, 2 or 3, then Hakkar number will be 2, 6, 10 or 14 pi electrons. And this cyclic ring will be show aromatic character. First, what is planar? This is benzene ring in which all the p orbital present sidewise are present in aligned form in a specific plane. That's why it overlaps sidewisely and results in the formation of 3 pi bond. If one p orbital is present at 90 degree to that of second p orbital, then it results in no overlap and it results in the formation of no pi bond. So any cyclic planar and conjugated ring which contain sp2 carbon atom show aromatic character. Seventh fact is those cyclic compounds which consist of more than 10 carbon, which have alternate single and double bond are called anolines. Anolines are those cyclic compounds which consist of more than 10 carbon atom. Then we called it anolines. The size of ring of an anolene is indicated by the number of carbon atom given in square bracket. This number in square bracket indicates the number of carbon atom. This is cyclodecaene, contain 10 carbon atom. in pi bond. So the number of carbon atom is represented in square bracket, which is 10. 8th fact is non-aromatic. What is non-aromatic? A planar cyclic conjugated polyene showing neither stabilization nor destabilization are said to be non-aromatic. For example, cyclobutadiene. Cyclobutadiene is highly unstable as their open chain analogues. The reactivity of cyclobutadiene is same to that of their open chain analogues. In cyclobutadiene, the middle degenerate non-bonding pi molecular orbital have one electron with each with their spin parallel. Cyclobutadiene have two electron unpaired and degenerate pi molecular orbital. That's why it is considered as non-aromatic. And this is an open shell structure. 9 facts about is antiaromatic. If the number of pi electron is in cyclic polyene is 4n, then will be considered less stable than their open chain analog molecules. Such a planar cyclic conjugated polyene are said to be antiaromatic. 4n means if n is equal to 1, then 4n is equal to 4 pi electrons. 4n is equal to, if n is equal to 2, then 4n will be equal to 8 pi electrons. For example, cyclopropenyl. Cyclopropenyl in anion form, the electron is present in anti-bonding pi molecular orbital. If we take its open chain analog in anion form, then electron become paired in non-bonding pi molecular orbital. So cyclopropenyl anion is less stable than propenyl anion, or is less stable than their open chain analog, and this cyclopropenyl anion is anti-aromatic. Hakkar provides explanation based on molecular orbital theory for his 4n plus 2 pi electrons. Hakkar discovered that there are two distinct, different patterns of pi molecular orbital energy levels, which is based upon the number of carbon atoms constituting the ring system. This pattern is for a planar regular polygon with even number of carbon atoms, such as benzene, can form even number of pi molecular orbital. The dots. This pattern is for a planar regular polygon with even number of carbon atoms. It consists of lowest pi molecular orbital called bonding pi molecular orbital, which is lowest in energy state. The middle are called non-bonding pi molecular orbital, and the highest are called anti-bonding pi molecular orbital. If we take the example of benzene, which consists of 6p orbital and 6 electron, if we accommodate in this, we get closed structure, and it is according to Hakkar rule. So an even number of carbon atom, Hakkar show this pattern. This pattern is for a planar regular polygon with odd number of carbon atom. Can form odd number of pi molecular orbital. In this pattern, there is no non-bonding pi molecular orbital. The lowest are called bonding pi molecular orbital and the highest are called anti-bonding pi molecular orbital. Cycloheptatriene, 7 carbon member ring, contain 1 carbon in the methylene carbon in the form of sp3 hybridized form. If we remove 1 hydrogen, then this cation in cation form it show aromatic character. And this pattern is for cycloheptatriene. Now how we can determine the energy levels in a cyclic aniline if we inscribed a figure in a circle in such a way that one vertex at a bottom of the circle is shown below. Each vertex will correspond to the bonding pi molecular orbital. The vertices below the horizontal diameter correspond to the bonding pi molecular orbital. The vertices above the diameter are called anti-bonding pi molecular orbital, and that which is present on diameter are called non-bonding pi molecular orbital. Hakkar explained the stability of aromatic ion. Those ring which is composed of 3, 7, 11, 15 can lose an electron to yield a cation. In cation form it will show Hakkar number. That is, the number of pi electron become equal to Hakkar number. This is cyclopropenyl. This is cycloheptatrienyl. The ring which is composed of 5, 9, 13, 17 carbon will show in anion form the aromatic character. Nonbenzenous aromatic compound. This is an isomer of naphthalene called azolene. It consists of 7-membered ring and 5-membered ring. The 7-membered ring consists of 7 pi electron and the 5-membered ring consists of 5 pi electron. How it consists of 7 pi electron? The 7-membered ring consists of 3 pi bond or 6 electron, but we consider the red dot, the electron that share with 5-membered ring with also this 7-membered ring. So it becomes 7, and this the second dot, red dot, this is the electron of 5-membered ring, also electron of 5-membered ring, that we also consider this electron with this 5-membered ring. So in this ring the electron become 5. By transferring one electron from 7-membered ring, the electron in 7-membered ring become equal to 6, and that in 5-membered ring it become also equal to 6. So it obey Hakkar rule. From experimental evidence, the 5-membered ring show reactivity or reaction occur at 5-membered ring. Why? Because those rings which have less than 6 carbon or more than 7 carbon show the phase of angle strain. Polycyclic benzoate aromatic compound. The aromatic compound which contain more than 2 benzene ring in fused form. For example, naphthalene, anthracene, pyrene. This is naphthalene which contain which contain 10 pi electron and 5 pi bond. So 10 is according to Hakkar number, it shows aromatic character. The second is anthracene, consists of 3 benzene ring in fused form, 7 pi bond and 14 pi electron. It is also a Hakkar number and show aromatic character. The third one is phenanthrene, consists of 3 benzene ring in fused form. It also consists of 7 pi bond and 14 pi electron. The fourth one is pyrene. The most important is pyrene. In pyrene, 8 pi bond are present and 16 pi electron. 16 is not a Hakkar number, so in this case we consider only the side electron. We ignore the inside electron. If the 2 inside electron is not shown by red dot, and we count only the peripheral electron. If we count the peripheral electron, the number of pi electron is 14, so it is according to Hakkar number. Homo aromatic system which contain more than one sp3 hybridized carbon atom and conjugated ring, also show aromatic character. For example, cyclooctatetraene, if we dissolve this in acid, one of the double bond is added, a proton is added to one of the double bond, giving rise cyclic cation, in which one of the carbon is the form of sp3 hybridized atom. How they can show the aromatic character? This sp3 carbon atom becomes out of plane and it shows its arrangement in such a way that that the conjugation is possible and show aromatic character. Jazakallah.